All right, good morning, everyone. We are looking at our next topic with parallel lines and transversals, and this time we're reviewing our next section, which is equations of lines. Because remember, our goal is to take these parallel lines that we've been working with and the transversals and be able to put them on a grid and work with them that way. So last time we reviewed how the different ways that you can find the slope. So now we're going to use those slope to make equations and start to see what's needed to make parallel lines and what's needed to make possibly perpendicular lines. So let's jump right in this. Okay, so right now we're looking at slopes that would be parallel for the lines. And so the clue here to look is for we need the exact same slope. They have to be identical. So we need to look for the exact same slopes, which means they need to either both be positive or both be negative and have the exact same value. So if the original line has a slope of 1/3, like it says there in the problem, M1, slope 1 is 1/3, M2 or slope 2 has to be exactly the same, 1/3. So that way we get parallel lines. Now, perpendicular is a little different. Perpendicular, we need two things. First thing that has to happen, oops, sorry, that's a little big. First thing that needs to happen is a sign change. If we start off positive, our new slope for perpendicular must be negative. So right now, looking at our slope 1, M1, it is a positive 1/3. So my new one has to be negative. The second thing I need is to take the reciprocal, which means that we need to flip the fraction over. Okay, that's what reciprocal means. Flip that fraction over. So guys, if your fraction is originally a 1/3, move the 3 to the top, move the 1 to the bottom. So 3/1. So a -3/1 really just means my slope is a -3. So notice how again we have 3/1. So I'm going to put one more example up here. Let's say your original slope starts off with a 2. Then remember, we can show this as a fraction by putting it over 1. And now I can see what the flip needs to be. So first things first, change the sign. Flip that fraction over, so 2 goes to the bottom, 1 moves to the top, so a -1/2. So there would be another example of reciprocal when you start off with maybe a whole number instead of starting off with a fraction. All right, so we're going to be using these different ideas of slope with our kinds of equations. So we saw a little bit about this particular y equals mx plus b equation when we reviewed slope. But let's review it just one more time here. All right, so remember the m that's in our equation here, that is our slope. So whatever number is in front of the x, our coefficient, that is going to be our slope value. That's going to tell me that rise over run that I need, especially if I have to go graph. The b is your y-intercept. Okay, and remember, as a coordinate, that would be 0, b. Okay, that would be 0, b. So again, the b is our y-intercept. The m is our slope. So let's use those and practice with this first equation we have here. All right, so our m needs to be the coefficient of x, which is again the number in front of the x. So that would be a 2/3. The b is our value at the end, your constant with no variable with it. So notice I did box in the minus sign because when I use it for a y-intercept, that subtract 4 when I graph it, is going to be the same as a -4. And again, we can also have it as a coordinate, 0, -4. Either way is considered the y-intercept. Just depends on what are we working with at the time. All right. Now we have another form of a line that you should have reviewed in Algebra 1, and this is called your point slope form because it has a point and a slope in the situation. So again, point slope form. So they give you a point and they give you a slope of the line, and that's all we have for those two. So we use this when all we know is just one single point on the line that's not the y-intercept, and we know a slope. So the point that they give us in this equation, that is your x1 and y1. And notice where those are sitting in your equations, x1 and y1. Now we have the slope, which is still the same m. Okay, still the same m there. So we're going to see how we use this information to write out and find the information from our equations. All right, so now we've got a point, is what we need to find first. All right, so remember, there's our first coordinate, the x1, so +1. There is our y1, the +3. So there's the coordinate that's on my graph. And again, whatever is in front of the parentheses, remember our m is in front there. That is our slope. So we're going to be using that form of an equation here in just a little while when we look at some of our examples. Now, the last two that I wanted to talk about, especially with horizontal and vertical lines. So these have specific equations that go along with them. All right, when we are looking at a horizontal line, that is the line that is going, it's a flat line going left to right. And like it says, horizontal lines have a slope of 0. And their equations are always going to be y equals, and then just a number. And whatever that number is, whatever the y number is of my point, that's what we use. Whatever number's being hit on the y-axis. All right, vertical. Vertical lines are the ones that go up and down, and these have an undefined or no slope. So these again are the x equals a number equations. And this would have an undefined slope. Now, when we deal with, excuse me, when we deal with perpendicular for horizontal and vertical, these are the perpendicular of each other because we can't have 0 and undefined. They do not have signs. But these two lines, 0 and undefined, whoops, sorry, let me make that a little bit bigger. So 0 and undefined are perpendicular slopes. Remember that upside down T means perpendicular. They just don't have a sign with them because again, 0 doesn't have a positive or negative and undefined doesn't have a positive or negative. So just be aware of that. Those are the only kind of exception to take the reciprocal and the sign change rule for perpendicular because these don't have a sign to start off with. So let's look at page 2 and practice out these examples. All right, so example 1, we've got just a little review from last time. How do we find the slope if they're giving us 2 points? So remember, we first label these 2 points, x1, y1. x2, y2. And to find our slope, whoa, that's way too large. We start off with y2. So that is our -8 minus y1, which is a 5. And then we do the same pattern for the bottom, x2 minus x1. So that is a -5 minus a -3. And let's see what we get. All right, -8 minus 5, that is a -13. -5 minus -3, well, remember, minus a negative becomes a plus. So we have -2. So now let's clean this up and simplify this down because we don't want to leave negative over negative. So my final slope, 13/2. And that's our final, guys. We're not going to take these to decimals because slopes love fractions. So definitely leave it as your simplified or reduced fraction. All right, let's come over to the next one. Find the equation of a line whose slope is 4. So right now we have a slope that is 4. And it says it crosses the y-axis. So that's your y-intercept at 0, 2. So that means that 2 is our B number. So when I use these two values to make my equation, we use the y equals mx plus b. Well, so that's always our start. So I have y equals, my m is a 4, so replace that, substitute. My b is the 2, and it's positive, so plus 2. So there's my equation for that one. All right, next one down, number 3. Now we're going to determine if these lines are perpendicular, parallel, or maybe neither. Maybe there's not maybe they're not the exact same slope, but they're not, there's not a sign change and the fraction flip over in a reciprocal. So let's see what we have. Let's check out the first equation here. So we have 2y is equal to 6x plus 12. Now, for us to solve this and figure out what your slope is, guys, it's got to be in y equals mx plus b. Right now, we're not in that form because we don't just have a 1y, we have a 2y. So before we can do anything to this equation, I need to divide out that 2 first, every single piece. So my first equation, 2 over 2 will cancel out. 6 divided by 2 is a 3. Bring your x down. 12 divided by 2 plus 6. Now we're going to do the same thing and solve the second equation for y, set it up for slope-intercept, because all we care about is what is the slope when it comes to parallel, perpendicular, or neither. So I need that +3 from the first one. So looking at the second one, we have 3y plus x is equal to 15, okay? Similar problem as before. We have to get the y by itself. We have to isolate that variable. So this time I need the x on the same side with the 15. So I'm going to minus the x from both sides, subtracting it. So 3y is equal to a -x plus 15. Now we can do the same thing we did before and divide out that 3. Okay, so now I'm left with y equals, in front of that x is an understood 1. So technically we have -1x here. So a -1 over 3x. 15 divided by 3 is a +5. And so this time my slope is a -1 over 3. And those two numbers are the ones I have to use for parallel, or perpendicular. So let's see what we've got. So we have m is a 3, and for the reciprocal, I'm going to just put it over 1 for the moment. It just makes it easier to check for perpendicular. Our second one is a -1/3. All right, so these two numbers are not exactly the same. So parallel is out. They're not the same. One thing I do notice, from M1 to M2, there was a sign change. And notice the fractions flipped over. The 3 moved down and the 1 moved up. That means there was the reciprocal. So there was a sign change, the fractions flipped over. That means these are perpendicular. These are perpendicular. All right, let's check out the next one. Number 4, write an equation in point slope form of a line that has the given slope and a given point. All right, so we're just writing an equation. So remember, we start off with, I'm going to write the equation over to the side here. Y, I'm going to zoom in. Minus y1 equals your m times x minus x1. So again, guys, we're only plugging in at the y1, the m, and the x1. Everything else stays put. So we have our m. So right now, if my m is a -2, I'm going to have -2 there. Now I have my x1 and y1. So those values are going to come in. So instead of y1, I have a -2. And instead of x1, I have a 4. So let's clean this up and put everything in its right place. So y minus -2 equals our m, which is another -2, parentheses x minus our x1, which is a 4. All right, so the only thing I need to do now is just clean up any minus negatives that I might have here. And I've got one of them. Right at the beginning, minus a negative really should be a plus. So then my final equation, y plus 2 equals -2 times x minus 4. And that's your final. Just plugging the numbers into the right position, substituting them in, and then cleaning it up if you have to. All right, now our second to last example here says that we are given line G and it has a slope of a -1/2. Find the following. So first off, we need a slope-intercept equation, y equals mx plus b, for an equation for a line that is parallel to the first one, then a y-intercept of 1. Okay, so right away, if they're giving me my y-intercept, that means I have my b value. If I need parallel, I need same slope. So that means for this first one, I'm going to use that -1/2. So my m is a -1/2. My b value was that +1. Now I can write my equation. So y equals -1/2 x plus the 1. And there's my parallel. Now we need a slope-intercept equation for a line perpendicular. So that means this, for the slope, we're going to have to do the opposite reciprocal, and it passes through a certain point. All right, so again, our original slope was a -1/2. So remember, the perpendicular has to have a sign change. So if it starts off negative, now it needs to become positive, and the two numbers need to flip over. So a +2/1, which really is just a +2. So there's our new slope. We have a point, which is -2, -1. Now, since this is not your y-intercept, that means they are in fact giving us x1 and y1. So guys, we're going to have to use the point slope form here and work through it and get it down into y equals. Very much how we solved for y on our other equations. So let's plug it in and see what we get. All right, so our equation is y minus y1 equals m times x minus x1. Let's plug everything in that we know. So y minus y1 is a -1 equals, our slope is a +2, x minus x1 is a -2. All right, so let's clean this up a little bit. Minus the negative, remember, becomes a plus, and we've got 2 of those this time. So really we have y plus 1 equals our 2 times x plus 2. All right, so we need to clean this up because our goal is to get that y all the way in front by itself. So guys, leave the y where it is. Before we can subtract away that 1 though, we have to take care of those parentheses. Order of operations says do that multiplication first with your distribution property. So y plus 1 is going to stay there for a moment. 2 times x, 2x. 2 times 2 of 4. Okay, now this looks similar to our previous equations. And guys, now you can minus the 1. So minus the 1 from that 4 on the other side. And we have y equals 2x, 4 minus 1, +3. And there's our equation. All right, so the last thing, guys, that I want to talk to you guys about, sometimes when our lines are not parallel and they're not perpendicular, sometimes they can fall into that neither category. So neither can happen in a couple of ways. If your 2 lines are on the exact same grid, the exact same plane surface, you can have neither. That's where we get maybe vertical and linear pair angles. So the 2 lines cross, but they're not perpendicular. They don't do it at a right angle. The other option we have are what's called skew lines. So more specifically, skew lines are lines that are non-coplanar. Sorry, I'm going to make that just a little bit bigger. So non-coplanar. So these are not on the same surface. These lines are not parallel because they're not going to intersect. And they are not intersecting. So we've got a couple of pictures here. So one way that that could happen, I have 2 separate planes. Okay, plane P on top, plane Q on bottom. It's like holding a piece of paper above another sheet of paper. So no matter what's on that first piece of paper on top, it's never going to touch what's on the bottom piece, the bottom plane, or that bottom sheet of paper. Okay, because again, they're the planes themselves, those surfaces are not touching. So line A, that's here in the top plane, notice it's kind of slanted going left to right, while the line below it on the other plane is going a different direction. But again, they're not perpendicular because the 2 lines don't touch each other, and they're not parallel because they're not on the same plane. And so that's where the non-coplanar comes in. So these lines would be skew. So line A and B again are what we call skew lines. Another way to think about it is if you have maybe a box. Okay, so think about a tissue box that you might have. Right now I have line HG, which is on the top of my box, but it's going left and right. Well, another line I could have on the box, another edge, line AB. Line AB is on the bottom of my box, and it's going front to back. So these 2 lines, again, are not going the same direction, They're not intersecting and they're not parallel, not on the same surface of this box. So these two lines would in fact never touch, because again, line HG is on the top, line AB is on the bottom, and they're going completely different directions. So line AB and line HG are skew as well. So these are just types of different equations that could fall into the neither category, okay? But again, neither could also be two lines that are on the same plane that do cross, they just don't do it at a 90-degree angle. They don't become skew until they go to two separate surfaces or two separate planes. All right, guys, so I hope you enjoyed learning a little bit about parallel and perpendicular equations of lines and what to look for. Please don't hesitate to reach out to me if you have any questions, and I hope you have a great rest of your day.